Right, in this video, we're going to do a very brief introduction to how we can start sketching polar curves. In fact, what this video is really going to do is just ensure that we know how to think about polar curves and polar coordinates. So remember, when we're thinking about polar curves, polar coordinates, we're thinking about that polar radius is some function of the angle off of the x-axis. So actually, before we jump into any particular examples, let's actually just do a couple quick reminders of how to think about polar coordinates. So we're still thinking about polar coordinates living on the XY plane. And remember, we define a polar coordinate given off some angle from the x-axis. And then we have to ask ourselves, how far at that angle are we actually moving across? So that's how we define our polar coordinates. And just so we're on the same page, let's just practice a couple things first. So for example, we're just going to look at different angles together. So if we have an angle of, say, pi over 4, this is our angle of theta equals pi over 4. And we're asking ourselves, how far along that angle do we have to march? So this feels very similar to kind of the example we just did. So if we're asked to go out a distance of 1, we would march a distance of 1 along that and plot that as the point then. Well, our theta is equal to 1 comma pi over 4. But remember, if we're given a negative angle or a negative r value, say we're interested in the point r theta is equal to, let's say, negative 2 pi over 4, we have to think about what that means. We still think about, well, if we're going out an angle of pi over 4, we can still think about that we're going over that angle. We go out a distance of 2 normally. So this would be the point, not the point we're actually interested in, but this would be our theta is 2 pi over 4. Again, we're interested in negative 2 pi over 4, but because of that negative r value, what we do is reflect over the origin. And we still think about that at the same kind of angle extended off of pi over 4, we would just flip this point over the origin and land here. So this would be our theta is equal to minus 2 pi over 4. So that's the point we actually want down below. And the only reason I bring this up is I think compared to rectangular coordinates, we always have to ask ourselves, instead of going out a distance and up a distance, we're thinking first in terms of where is this angle from the x-axis? Which quadrant is this angle actually putting us in? And then at that specific angle, how far am I moving out from the origin at that particular angle? So let's do a couple examples of this. The first example I want us to think about, just to warm up our brains here, is r is equal to 3. So this is our polar coordinate or a polar curve. R is equal to some function of theta, except that function of theta is just 3. So what does that mean? Well, if we're thinking about the polar radius, again, we're asking at what angle is the polar radius equal to, et cetera, et cetera. In this case, what this looks like, or the way we can interpret this is, well, for all angles, r is equal to 3. So what type of shape does that actually sketch out for us? Because what we're saying is it doesn't matter now what angle we're actually at. So if we just draw our XY plane, what's that saying again is, say I'm at an angle over in the third or the fourth quadrant, it doesn't matter what angle I'm at, I'm always a distance of, say, 3 away from the origin. Or if I'm in the first quadrant, it doesn't matter what angle I'm at, I'm always at a distance, say, 3 from the origin. Second quadrant is the same thing. It doesn't matter what angle I'm at, I'm always a distance of 3 from that origin. And you might see what shape this is starting to sketch out. In fact, it's actually going to sketch out a circle for us of radius 3. Because r is always equal to 3, no matter what angle we're considering here. So that's how we can think about this. R equals a constant. Well, that's a circle of that specific radius. So you might be wondering, well, this is one of the perks of polar coordinates. If we're dealing with these circles centered at the origin, it's really easy to describe that case. R is just equal to some number. Let's actually think about a slightly different case now. What if what if we don't even consider r? What if we just have, say, theta is equal to 3 pi over 4? So first, just sketch our xy plane. Well, if theta is equal to 3 pi over 4, that's putting us in the second quadrant. And we're basically looking at the some distance along that angle. So again, the angle's off of the x-axis, and we're just some distance along that angle. Now, what I want us to think, though, is we're not told what r is. So the way we can actually interpret this, just like we did the previous case, oops, I took a little bit at 4 with us. Is for this type of polar curve, r could be anything. It could be any positive number. It could be any negative number. We're not told what r is. And it's because of that we just know, hey, we're at some angle 3 pi over 4. So what that means is we could start at the origin and say, you know what, maybe r is something small. Maybe it's slightly larger. Maybe it's something larger than that, or it's very, very large. We're just going to extend ourselves at that particular angle as far as we want. So this is actually tracing out a line for us. Now, the important thing to note is at this particular angle, if we're going out in that direction, what that means is these would all correspond to positive r values. So I'll just write a little flag. This is positive r. But since we also don't know what r is, r could be negative. And what happens when we have negative r values? We reflect ourselves symmetrically over the origin. So if r is negative, we actually extend as far as we want in quadrant 4 as well at that same angle. So I'll just flag on this side, these would be the negative r values. So the things to consider here is what we just saw. If theta is just equal to some angle, no information about r, that's going to trace out a line that goes through the origin. And we have to consider both what if r is positive, what if r is negative. So we have that line extend completely through the xy plane, just at some particular angle, like in this example. All right, let's do one more example here. This example might be a little more exciting, but let's consider the following function where we have r is actually a function now of theta. But what that function is, let's just make it something like theta squared. And for this consideration, let's only consider, say, positive values of theta. Or positive or equal to 0. So what does this curve actually sketch out? So let's think about this for a few seconds. So again, our polar curves live on the xy plane. If theta is something very small, our r is very small. As theta gets larger and larger, our r is going to get very large. So for example, at small theta values, our r will be rather small. As theta gets larger, our r will increase. So I'm just kind of sketching a couple ideas to get us warmed up here. As theta increases, our r increases as well. And this will keep happening as we keep going around and around as angles are increasing off of the x-axis. So again, just drawing some as our angles increasing as we're going around this plane. We can kind of see maybe what shape this is ultimately going to sketch for us. So again, at any of these angles, our angle's increasing and r is increasing by the square of it. So if we actually go ahead and sketch this, the shape that this actually starts sketching out for us, oops, this is really bad, I apologize, is actually a spiral looking shape. Where actually, as theta gets larger and larger, this angle is going to keep getting larger and larger when we square it. So ultimately, r is going to keep increasing. And as we keep going around and round, because theta can just keep going, 0 to pi, there's no reason we could go 2 pi to 4 pi, 4 pi to 6 pi, 6 pi to 8 pi, and so on and so forth. We are really going to trace out a spiral in this case. So this shape really does trace out a spiral in the XY plane. Because again, as we keep going around the XY plane, that angle is getting larger and larger. Oops. That angle is getting larger and larger. And so will r then, since we're squaring whatever that angle is. So remember, when we're plotting or sketching anything related to polar curves, we're really asking ourselves, what is happening at a specific angle? How far are we extending in that direction from the origin?